Hi, it's me again, back for another short video in the series to talk about how refracs can help make America's old oil and gas wells great again. Last week we talked about getting the right team in place, making sure you got the right disciplines involved, and you got the right information going forward. This week we're going to talk about determining the size of the prize, just what goes into determining what the remaining oil and gas in place is, before we actually get into the mechanics of getting it out, which is the next two sessions. The concept is fairly simple. What was there originally and what's come out, and what's the difference is what's left. The devil goes in the details to make sure that you have a good calibrated petrophysical model tied to core and production, and it makes sense and it's repeatable, and you can get reliable results with a variety of log suites. Companies that are in there going, telling you, they tell you there's 10 minerals present and what the properties of each one are to get your final answer. Typically the rule of thumb that's been pretty constant over the years is one curve is one output, unless you've got some other information. So, it's these fancy models, sometimes they look good, they're colorful, but are they really right? How do they tie to core? And more importantly, how do the results, the oil in place, gas in place, match up with reasonable recovery factors? Can it actually predict production? That's the key, I think, to an effective model that gives you your oil in place or gas in place. But start with a core calibrated model. You always want to try and calibrate your model locally if you can. Regional models are fine, or a good place to start, but try to get local data if you can. And then from there, normalize your logs. That's very important. It's not done quite often. It's not done. When you've got different vintages, normalization can be critical. We've seen, particularly in the resource plays, where your porosities are fairly consistent, but your height's what drives it. A little bit of error in porosity, say in a 200-foot Wolfcamp column, and throw off your reserves quite a bit. And the next thing you want to do is try to integrate it with geology. You're measuring an 8-inch piece of that rock, and typically your wells are a lot farther apart than that. Sometimes on the order of a mile, several miles, sometimes in these large regional studies we've done. And you want to map the individual properties, your porosities, your saturations, your net pay, and because those have geological significance. Sometimes people just map OIP and gas in place, and it's okay. I mean, it gives you an idea of what's going on, but it really doesn't have any geological overprint. Plus, it also doesn't give you any ability to QC your inputs. If you've got 8% porosity in 6 wells, and you couldn't normalize one of the wells because you didn't have a marker in there or didn't have enough data, and 10% in that well, something's probably needs to be changed. And same thing with saturations. You see a lot of people run the wrong tools. It's wrong resistivity tools. You have variations in saturation, which you really have to go back and look at that as well. And then map it all together, put it all together, and that tells you what your oil in place is. And then the key part there is try to validate it with what you think the effective producing height is as a function of the rock brittleness. With conventional rocks it's not that difficult, but in organic plays it's more problematic. Just what's the H and what makes sense. I've seen some areas that only produce from the propped height, which is 50 to 60 feet. Because no matter what you pump, because your shale plays, that closure time is so long and your break time is so quick, and you don't have any in slick water. There's no real proper transport there to start with. So what's propped typically from the rock mechanics models, what's actually producing. That's important, and that has to make sense. And tie all that together. And at the end of the day, you should have a model that can pretty much be calibrated back to production. What's your best practice as well as doing right now? I mean, like for instance, the studies we're doing in the Wolfcamp, 12 to 14% is your best practices range for Gen 2 and Gen 3. If you've got a well that's got 2% or 3% recovery factor, that's a pretty good refrac candidate, probably based on the volumetrics. Now you got to compare that to the economics of the completion, but by and large, that's the basic methodology. Is what could you be doing with that versus what it's doing, and that gives you your size of the prize. Next week we're going to talk about some of the issues involved with determining what happened the first time. Why is the oil and gas still there? It has to be a good reason. And also, you don't want to repeat those same mistakes. And we'll talk about that then. And then the final week, we'll talk about tying it all together with best practices. Okay, thank you for your time this week, and we'll talk to you next week.